Started? Okay, so hello everyone. Today we'll be presenting our SADT IA2, which is based on the paper leveraging the layered architecture for microservice recovery. I, Ruta Kulkarni, along with my teammates Parth and Bhavesh, will be presenting this presentation. So to begin with, what are microservices? Microservices are small, autonomous and loosely coupled services ideal for cloud-based applications. Traditional softwares often rely on monolithic architecture, which is becoming complex and hard to maintain as it grows. So the migration process from monolithic to microservice architecture involves two phases, namely identifying the microservices within existing applications and transforming the monolithic code to fit the microservice application principles. So this paper proposes an approach that prioritizes identifying microservices based on business capabilities and avoiding common anti-patterns. It includes three components: architecture extraction, a fitness function for evaluating microservices, and an identification process guided by the fitness function. So this paper has given a motivating example of a JPET store. So it is a web application with a typical three-layer architecture consisting of a presentation, business, and data layers. It involves four main features: account, catalog, shopping cart, and order management. So the ideal microservice decomposition will be to extract microservices for each feature along with their business functionality, logic, and data access. The proposed approach leverages established design patterns and anti-patterns to guide the identification of microservices. It encourages decomposition based on business capabilities, avoiding pitfalls like the wrong cuts and shared persistence anti-patterns. So the three-step identification process is divided into three steps. First is the recovering class artifacts from the source. Second, categorizing these artifacts into different layers. And lastly, then using these internally layered artifacts to identify microservice candidates through automatic clustering. The approach also includes a quality metric to assist in the identification process, ensuring that the microservices are well cohesive and loosely coupled. This is the architecture diagram of the example given in the paper. Now Bhavesh will continue.
So let's talk about the threats to the validity of a study. So the internal validities are: one concern is there isn't a correct architecture for a system, potentially biasing a study. To address this, we have used two different metrics to evaluate our identified architecture. In future, we will also include additional assets and to evaluate an architecture. For experiment one, we have involved four individuals with diverse profiles to reduce the bias in constructing the ground truth. Additionally, we have used an expert decomposition for a separate team for production, completely removing bias to a case. So for the next slide, we will move to the external validity. Our experiment is limited to Java applications, so which does not represent the diversity in programming language used in the industry. While we try to mitigate this by selecting application of varying sizes for different sources, the lack of publicly available decomposition in the current literature limited our options. In future research, we aim to expand our evaluation to include more applications with publicly available decomposition and create a framework to evaluate other identification approaches. So to the next slide, we will talk about the research questions. The first research question we will be answering is: what are the effects of extracting the layered architecture on identifying the microservice candidate compared to native approach? The question assesses the benefits of understanding the monolithic applications layered structure into microservice identification. The methodology we use to answer the RQ1, there are three experiments are conducted. First experiment, we will use manual microservice identification, where experts use the decomposed by business capabilities pattern. So in the second experiment, microservice identification without recovering the layered architecture using the clustering algorithm. In the third experiment, we will be using microservice identification using the proposed approach involving layered architecture recovery and hierarchical and clustering. So I would like Par to continue with the remaining presentation.
So let us understand the layered identification approach. In this, our approach is to identify microservices. It is like a journey with guidelines and warnings. We leverage design patterns and steer clear of anti-patterns. The key elements of this approach are design patterns, which include that we have followed a pattern that suggests breaking down monolithic applications based on their business capabilities. This makes our microservices more business oriented. Second is anti-patterns. In this, we avoided pitfalls like splitting microservices based on technical layers, which can create complexities, or allowing multiple microservices to access the same database, which hinder independence. The three-step process in the paper that it involves, one is recovering artifacts, is that in that they extract class artifacts from the source code. Second is layered grouping, in which these artifacts into layers like presentations, business, and data access. Third is automatic identification, in which they had clustered it to make identify microservice candidates. And this approach, we can say that it ensures that they followed the best practices to avoid common mistakes and created well-structured microservices. So now let us discuss the future work of this paper and what can we understand that can be developed further and innovated further from the conclusions of this paper. So first is that future work includes a research-based algorithm, something like investigating the use of search-based algorithms for microservices identification and compare them to results with clustering methods. Second is we can make a static and dynamic analysis. In that, we can explore combining static and dynamic code analysis for more accurate microservice identification. Third is documentation utilization. In that, you can utilize available documentation in the architecture recovery process to enhance the identification process. And last is source code refactoring, in which the future work can include investigating code refactoring to materialize the identified architecture based on previous work. So what do we understand from the conclusion of the paper and a gist of the paper is that the main contribution, the paper introduces an approach to identify microservices from object-oriented source code by leveraging monolithic applications, layered architecture, and reducing microservices coupling. As we learned previously in the paper that it is completely Java-based. Secondly, it has a positive impact. Experimentation demonstrated that incorporating information about monolithic applications architecture improved the microservices identification process. Third is the key takeaways are the importance of extracting internal architecture for understanding the monolith and avoiding any unknown anti-patterns is highlighted in the paper. And lastly, applicability. In this, the approach can be likely be applied to different systems types beyond object-oriented ones. Thank you. That was our IA2 presentation.